The grand challenge itself deals with the technology behind our national defense, namely, the technology involved with detecting nuclear threats, defending against imminent nuclear threats, and recovering from nuclear threats. We live in a nuclear age. More and more groups are obtaining nuclear weaponry, or at least the means to access it. Reactors and silos are located across the globe, most of which remain completely hidden from the rest of the world.
So basically, nuclear weaponry began with the invention of the atomic bomb in World War II. This invention marked a global transition in politics and international relations. The detonation of the atomic bomb dropped on Hiroshima, ending World War II, sent a global message that war combat was now being escalated. No longer was war solely based on troops fighting troops. It was now based on science and technology fighting with science and technology. This ideology moved into the Cold War and still impacts our world today.
From the 1950s Cold War into today, nuclear technologies are always being monitored, improved, and expanded. We as a world are subject to nuclear threats daily, as we have seen recently in the media. Nuclear war is now something considered normal by society. As engineers, our goal is to use applied sciences within technologies to improve the lives of people. Nuclear weapons do not align with this goal. Our approach to solving this is to engineer new technologies to help protect people from nuclear threats.
The solution to a problem such as nuclear terror cannot be a totally engineering one. However, there are some engineering possibilities. If you take the example of the modern day North Korea, they have the ability to launch a nuclear missile assault, the capital of South Korea, which would be catastrophic and needs to be avoided at all costs. There are already missile defense systems in South Korea, so instead, we will address the problem of an intercontinental ballistic missile, or ICBM, possibly being fired by North Korea. ICBMs are far more difficult to stop than regular missiles because they actually leave the atmosphere. Also, we will address the possibility of a nuclear warhead being strapped to an ICBM, and that is a real possibility. The best way to stop a nuke is to disable it with an electromagnetic pulse, or EMP. But militaries have realized this and started equipping nukes with special plating that protects them from these EMPs. The next best thing is to shoot the missile like this out of the sky without causing a detonation and causing it to drop in a place where no harm will come to anyone.
The answer to this problem could come from railguns. Railguns are a very real weapon currently employed by the US Navy. The reason a railgun could be very effective at shooting down ICBMs is because they are the fastest kinetic weapon ever created. A kinetic weapon is a weapon that uses pure force instead of an explosion to do damage. This type of weapon is very effective at disabling missiles because they will not cause the missile's warhead to explode. Railguns have not yet been used to shoot down missiles in this fashion. However, with more testing and more accuracy refinement, this could be very possible.
As far as my current thoughts on nuclear terror, what I believe really needs to be done is to have systems in place to protect the United States. The one thing we can't control in a realistic way is what other countries do. If they determine that they're going to design and develop nuclear warheads, I don't know if there's a practical way for us to stop that. What I do know is that the United States has the capability and the technology to design systems to defend against that. Now, whether that's a system that shoots them out of the air, obliterates them into a configuration where they can no longer sustain a controlled fission reaction, or if they do, it's at an altitude high enough that Americans aren't put at risk, or maybe it's some kind of guidance system where we take control of the warhead, some electromagnetic system where it no longer allows the person who launched the weapon to control its guidance and its detonation.